Hi, everybody. This is Mr. B. I'm the middle school engineering teacher at Hayfield Secondary School. And what this video is about, it is about white box learning, the structures module. And when you get to the engineering section, if your teacher has enabled game mode, okay, that means you are going to be building bridges, advancing through different levels. You're going to be competing with other students in your class, maybe outside of your class, schools, yeah, other schools in the district, maybe even as you get it through higher levels, you'll be competing with students in other states across the country. But you have to build a bridge at each level that meets a certain specification. It has to meet that specification or you cannot advance, okay? Well, a lot of students get wrapped up at this stage, and there's actually a very methodical process we can follow, which I'm going to teach that to you right now, that will allow you to design a bridge that meets the specification for a given level and do it in a very short period of time. And I think you'll see that it's actually pretty logical too. So this procedure we're going to follow is right up here. It's a 5-step procedure. So when I say spec, we really mean specification. And the key items we're going to pay attention to in the specification, when we look at it in just a second, we really want to pay attention to size, capacity, and cost. And there is a direct relationship between the size and the cost. We have a budget. We can't spend just whatever we want on the bridges. It tells us how much we're allowed to spend. So size and cost have a very direct relationship because the larger a bridge is means the more materials that you would use to build it, and it would cost more, okay? So that's the first thing we're going to pay attention to when we are looking at that spec, step one, okay? So let me flip over here. There we are, okay? So this is, the main screen in white box. Let's say you finish the research section, you're ready to go to engineering, and you're going to start building a bridge. So let's do this, okay? Just go over to this folder symbol there, and we're going to build a new bridge. And we'll keep things simple. We're going to call it level 1, okay? That is the first level of competition. In the upper left corner, you can see that we are on level 1, and we have not earned any points in level 1 yet because, well, we haven't done anything. So let's go over here to outputs, the specification. Right here, design specification. That's when I say spec, okay? It's just the short form of the word specification. There it is, okay? And so the things that we talked about, the size is right there up front, and it says the length. They give you a range. It can be between 250 and 300. As long as it's in that range, it is considered in spec. It would meet specifications, okay? And again, with the width and the height, and that pretty much covers it, your length, width, and height. Those are dimensions of your bridge. And you can see the minimum and maximum. You might want to stop at this point and actually just take a piece of scratch paper and write these things down. I know I did, so I don't have to keep jumping back and forth to these screens. Span is the opening that the bridge would actually, span. So, for example, if a bridge goes over a river, the span of the bridge would be the width of the river that it is covering. Number of bays are the number of sections in the design, and we're going to talk about that in a little bit. Okay, so let's jump back over to engineering and start designing this bridge. I made note here of the size parameters. Oh yeah, and let's down at the bottom here. I talked about you got to make note of capacity too. That's very important. In other words, how much will this bridge support? And then of course our budget. And I'm going to make note of that stuff as well. And go back over to engineering now. Okay, there's some tools. Whitebox has some tools that makes life a lot easier in doing this. Let me switch back to camera. Okay, so first thing we're going to do is we're going to set up these size parameters, right? And we do that right in the very top two menus of Whitebox. And I wrote these things down, but let's talk about something for a second. Here's a bridge. This is a bridge one of my students built. Did a really excellent job. We talked about the length, height, and width of the bridge. Now, this bridge is actually from another level, from a different specification, but it doesn't really matter, okay? What I'm here to tell you is there is really no advantage if you're trying to enter a competition and you're trying to keep your costs down to the minimum, because the way Whitebox works, the more efficient your bridge is, the more points you earn every time you compete with that bridge. You go into the competition, okay? And actually, let's go do a competition real quick, all right? So I am just going to save this bridge. If you click on View 3D Structure, it does give you a default design. Now, do not get excited about this default design. It is not very good. They always give you a default design in whatever project you're doing in Whitebox, but it's just a starting point. It's not going to be what you want to do. Matter of fact, on this one, if we go over to the specification, you can see we have items in red. If they are in red, that means they're out of spec. So this default bridge they gave us, for example, is too wide. It's 80 millimeters wide, and in this particular case, it has to be between 50 and 75. We'll fix that later, okay? So don't worry about that, all right? The competition looks like this. First, we've got to enter the competition. And so we come over here and we just say save and enter competition. We can do this as many times as we want. So do not hesitate to enter in the competition and see what it's all about. So I just did save and enter competition. Now, if I go to the competition, okay, you'll see, oh, it actually has Engineer Anonymous. That's me, I guess. And I didn't set up my name. Sorry. So I'm going to choose, I can compete against anybody. So I could compete against myself. I could just go over here and say, oh, I want to compete against one of these other people. And these are various students in my classes. And I'm just going to pick one. This one looks interesting. A big whale. Okay, we'll pick that one. And we'll start the competition. All right. Oh, they don't have to give you permission for you to compete against them. You just pick whoever you want. So right here it says, okay, big whale won. It's green. The main bunch of reasons it won. It's a stronger bridge. It's a lot cheaper bridge. Notice the cost. They got their bridge down to $11. My default design is way too much. And mine didn't meet spec anyway, so I did not earn any points towards my level. What happens is when you design a bridge and you put it in the competition, it has to be in spec, okay? Or when you compete with it, you don't earn any points. When my bridge is in spec and I compete with it, and I can just go up here and click on this at any time, it shows that even though I competed, I don't have any points at all. All right. So we'll certainly fix that in a minute. I'm going to talk pretty fast. People say my videos get too long sometimes, and they're probably right. All right. So let's go over here. All right. First things first, let's get the size of this bridge figured out. Now I'm going to ask you something. If my bridge can be between 250 and 300, because that's what the specification says. Let me close this. What am I going to set it to? 250, 300, somewhere in between? Well, I'm here to tell you, there's no advantage at all to set it to anything other than the minimum size. Think about it. As long as I'm in spec at 250, why would I make it any longer? If I make it 300, it's a 300 millimeter bridge. Is a longer bridge going to cost more money? Sure it is. more wood, more cost, and it's going to make it harder for me to meet my budget. Okay. So on all, just I'm going to tell you this right now. All the size parameters, except for height, there's a caveat with height, but all my size parameters, I'm going to make them as small as possible because it's going to build the cheapest bridge possible and make it easier for me to hit my capacity numbers and stay under budget. And there's one other thing we have to take into account. Okay. Um, all materials, have different levels of rigidity. And take this ruler, for example. A really long ruler, of course, can flex a lot, right? Really, really easy. But if this ruler was only 2 inches long, how much could it flex, right? So a shorter bridge is naturally going to be stronger without you doing anything except making it shorter. If it's longer, it's naturally going to be weaker because longer pieces of balsa wood are going to have a lot more flex in them than teeny little pieces of balsa wood. This is balsa wood. This is what we're using, okay? So that's another reason to keep it smaller. It's going to be naturally stronger just by design because it's not going to have as much flex. It's going to be stronger, cheaper, win-win, okay? Right. So let's get over here to engineering. Right at the top here, I'm going to go click on the tool symbol. So this tool symbol means, okay, what can I do here under bridge site? Bridge length, too long, all right? Minimum is 250. That's what I'm going with. And it changes the picture on the screen for you. The span, we have to leave that, okay? They tell us what the span is. So it has to be 200. Remember, it's in the spec right here, all right? Can jump back and forth pretty quick, so that's what I'm going to do. Next thing, we want to look at the design envelope. That's just the area. I'm not sure why they did that and they didn't put it all in one menu, but they didn't. So here we go. The width, remember, we're actually out of spec over here. It's saying we're at 80. It's got to be between 50 and 75. So if smaller is better, because it's cheaper and stronger, what am I going to set mine to? Well, I'm going to come over here and I'll set it to 50, okay? Height, leave that alone for right now. And we may have to revisit that later, but just leave it right now. The minimum is actually 30. I'm just going to leave it at 40, and I'll explain why a little later, okay? And the bays, when he went through the research section, they talked about the terminology used to describe a bridge. Remember, where all these individual pieces of a bridge are called members. The where members come together, where they're connected, are called joints. Let's see, what else? Oh yeah, the bays are these sections, okay? And so if you see here, they're actually 5 sections. 1, 2, 3, 4, 5. There are 3 sections that are square with a diagonal, and then there's the 2 end sections that are just triangular shape. There are 5. You can change that. Actually, yeah, I don't like having that many bays. It actually, you will do just fine if you reduce the bays. You can actually go all the way down to 3, but I just set it to 4. And this is like the keep it simple principle. If you reduce the complexity of your bridge, you also reduce the cost of your bridge. And of course, the width, it bumped back up on me. I did 50.3. I think that's because it's adding the, yeah. So don't worry about that. Okay, we're good. All right. There are 4 different design styles that you can choose from. There's the Warren 1, the Warren 2, the Pratt, and the Howe. One of these design styles is the most efficient of the 4. I'm not going to tell you which one that is. If you go back to research and look at these different styles, and remember this, what is the strongest geometric shape? The strongest geometric shape is the triangle. Go review those styles, and then you tell me which is the optimum design to use in your bridge design. I can give you a hint. It kind of looks like this, okay? That's just quick. All right, let's get back to it. Okay, so I've minimized the size of my bridge. Got to keep the span at 200 because that's what the spec says. I did get rid of a bay, so simplified things a little bit. And all right, now let's get back to the whiteboard. All right, so we've done that. Okay, we've reviewed the specification and we've set up the size of our bridge to match the specification. Check. All right. Next thing we want to do, it's all about capacity. That means, how much can your bridge hold, right? I mean, that's what bridges do, okay? So if we just go back over here a little bit, there it is. It is 300. We must meet 300. Our bridge is currently only holding 267. So we are in red ink. Notice there's no red ink up here with width anymore because we fixed it. Red ink is gone. That's good. We're in spec, but we're not in spec with our capacity. We need to change our design to do that. And you're going to see that it actually, if you follow this procedure, it's incredibly easy. All right, let's go back. 300, okay? So we want to do step 2 now, and that is set up our load test to the capacity in the spec. Maybe I should write here. In the spec. This is not optional. That's what they're telling it has to be, okay? So I'm going to do that. It's super easy. I just go over here and see where it says load test. That's what it just said on the whiteboard, right? Set the load test up. See? Load test. That's what I'm going to do. I'm going to go over to load test. I'm going to set it to what? I'm going to set it to 300 because that's what is in the spec. Now, that didn't look too exciting, but it just did something very magical and helpful. Now I'm going to go over here and click on Truss System, right? It's the Truss System chart. And you will really like this. Here we go. I'm going over to the Truss System right here. It's in the left menu bar. I'm going to click on, the eyeball. That means I want to see it. It just drew a chart for us. And guess what? This failure line is set to 300 because that's what we need it to be set to. And it has given us a lovely little chart here. And it is telling us precisely what members of our bridge are failing at the required capacity of 300 newtons. It is, remember how they name members? They just name them they just number the joints and then the endpoints where those joints are for a member. That's how they refer to it here. So look, there are 2 members right here that are over the failure line. Okay, so we're not reaching capacity right now. So all we got to do is fix those 2 members. Okay, well, how can we fix them? Well, let's look at our all of our members in here. Now, here's a little menu right here, and you can look at some of the members or all of them. Just click on all. Just click on all. All right. So 6, 7, and 7, 8. They happen to be the 2 at the top. Now, we can switch material. All right. We don't want to do that. There are 2 kinds of wood you could use for this project. One of them is basswood. Basswood looks just like balsa wood, but it's much more dense and it's a lot more expensive. So if you go to that chart and click, I want to use basswood, you're going to blow your budget, and there's no way you're going to do it for their budget. Do you remember what the budget was? Go back over here. It's $18.50. Right. Okay. There's no way you can build this bridge out of basswood for $18.50. Not possible. So you almost never want to use basswood. Matter of fact, I'm just going to say it. Don't never use basswood unless you've been given a really big fat budget. Okay? Just don't do it. All right? What you can do is you can use balsa wood, and we have real skinny little balsa wood, and then we have the 3.2 millimeter balsa wood. And that's the one we use standard. That's the one you've been seeing on camera. That is standard issue 3.2 millimeter balsa wood. And the default design just sets everything to this default balsa wood, and because it's good stuff, and that's what we usually use. Now, laminate. All laminate means, do you all know what it means? Did that pop up in the research section? Honestly, I don't remember. But here you go. Here's all it means. Okay, here's a on camera. Oh, over here, I got two cameras. This is a single piece of the 3.2 balsa wood. Okay, see it? Notice these pieces up here. They are two pieces of balsa wood that have been glued together. Matter of fact, all across the top, the sides, and the bottom. That's what we call laminated. And that is just taking two pieces of this balsa wood, and we put a ton of glue in between them, and then we kind of make a balsa wood sandwich, and we squeeze them together, and now it is twice as thick and twice as strong. So that's what laminate means, and that's the way we're going to go. We'd rather do that than use basswood, because basswood is really, really expensive. It's more than twice the cost of balsa wood. So I can use twice as much balsa wood and still not be expensive as basswood. All right. So that's what we're going to do. Here we go. All right. I'm going to go to 6, 7, and 7, 8. I'm going to laminate them. And you always have to click apply. Just don't hit enter. If you hit enter, nothing happens. I click apply. Now, those two members are no longer failing. Okay. And actually, I don't have to jump back and forth. I can just go down here and say, tell me about my bridge. I just clicked on the tool, and it's telling me right now, okay, your bridge is definitely passing the required 300. The floor down here, see where it says bridge? The floor is 465. The truss is 307. So your overall bridge is 307. So we pass. If we go compete with this, we'll get points. Now it's telling us what our mass is and what our efficiency is. The way they calculate that is really super simple. They just take the capacity of the bridge, in this case, 307.89 newtons, and divide it by the mass of the bridge. In other words, how much can your bridge hold weight-wise compared to how much your bridge actually weighs? So remember that efficiency is at 6,000, okay? So we can actually save this and go enter competition, all right? But yeah, we're not ready to do that yet, because we can do a lot better. We're going to keep on my little procedure, okay? So are there any other members that are failing? No, okay? So that was step 3, actually, step 3. We're still on step 3, all right? Actually, 4, sorry. Skipped ahead there. So we reviewed the spec. We set their load test up for what we need it to be according to the spec. And then we looked at this chart in here, really super helpful chart, web members, internal forces. And anything that was failing, going over that red line, because we set it, the load test to what the spec is and the capacity, we laminated them. We glued two pieces together. Now they're not failing anymore, okay? But there's something else we can do to reduce costs. Let's go look at that chart again. And we are almost done. See, there are some members on here like 3.7 and 3.8 and 3.6 and all these guys that are under such a small amount of load. In 3.7, it doesn't even show up on the chart. So ask yourself, let's go down to 3.7. What is 3.7 made out of? Well, it's made out of the default balsa wood. Remember, I'm trying to drive my price down. The lower I get my bridge, cost-wise, okay, the more efficient it's going to be, which means I'm going to get more points when I compete. So, could I switch 3.7 from the bigger balsa wood to the smaller balsa wood without really any worries at all? I bet we can. So that's all I'm going to do. I'm going to set it to the cheaper balsa wood and click apply. It still doesn't show up. It's under such little amount of force here. It happens to be the center one right here, okay? And if we go down here, look, my efficiency went up just a little bit. It was like 6,019 and now it's like 6,072. So what I would actually get more points, okay? Well, guess what, folks? Um, if we go after those changes and verify my design, you're done. You are absolutely done. Okay. So notice when I go, I'm verifying, that is the last step of this procedure. I'm verifying my design against the spec, and that's what's on the screen right here. No red ink. We're in spec. We're under budget. Okay. We're over $2 under budget. We meet all the size requirements, capacity requirements. So if we go and compete now, we can compete. Oh, first I better save it and enter it into the competition. Students forget to do that all the time. They're like, I made all these changes to my bridge and nothing different happened in the competition because you have to save the version. Okay. So save and enter competition. And so I'm coming over here and here is my latest. Oh, I'm staged. You always come in as staged. I'm still anonymous. I should change that. Anyway, I'm going to compete against somebody else. Doesn't really matter who. Let's go against Big Whale again. I think he's still going to beat me because he's cheaper. We compete. I should have already racked up some points here, but all right, there it is. We competed at 300 newtons. Both of us passed. And Big Whale still got me. Oh, that's right. His bridge is actually only $11. Okay. Um, but look at what happened to level right up here, the little trophy cup. I earned 73 points. Okay. Now, this account that I'm using does not, I haven't taken any of the quizzes under this user account. So if you got really good grades in the research section on your quizzes, you would have a bunch of points here as well. You cannot advance levels without taking the quizzes. So don't think you can just design a bridge and not have to do any of the quizzes because you'll never advance because it is a third of the available points that you need here. But anyway, look, I got 73 points. All right. Now, if I compete again, I will, if I make a design change and compete again, that will be what we call an iteration. An iteration can be viewed as another version of your bridge. And the iteration can be really minor. It doesn't have to be like some big design change at all. Every time you do an iteration, you get some points. You make a change to your bridge, you compete, you get some points. If you make your bridge better, more efficient, you'll actually get more points here too. So we got 73 points here. Let's go back over to engineering, and there's some things we can do. So remember, I just on this guy here, I only made that one piece there, that one member. I made it with the cheaper balsa wood, which made my bridge cheaper, which means it's more efficient. Are there other members here I can do that to? Yeah, absolutely. So I'm just going to do that. Let's see, 3.8 and 3.6 and 2.6 and 4.8. Now you saw them move a little bit because, you know, you would expect that you're using lighter weight wood. That means that wood is, you know, under a little bit more load because it's not quite as strong. And if we go down here and look at my bridge, look how much my efficiency increased, okay? It went up by like almost 400, okay? Because my mass went all the way down, went down quite a bit. My capacity is still really good. So now let's compete with this one. And I'm going to do save, enter competition. And real quick, I'm going to go over here and I'm going to compete. Um, I'll just click on my designs, easiest way to find it. And I'll go against, come on, qualifiers. Why isn't it letting me? I didn't know I was doing that. Anyway, let's go start competition. Looks like I'm competing against myself for some weird reason. That's okay. Notice my points up here while this is going on. I'm at 44% of the points I need to get to the next level. But let's just see what happens. I just, made a new bridge, saved it, and I got more points. So I got more points in the iteration. I only got a few more points in performance, okay? But I think you get the idea here, okay? Um, and you definitely have to do your quizzes if you want to advance. You need those points. There are other things you can do, like the floor here. When you look at the bridge summary on this guy down here, you'll see that our floor is actually a lot stronger than it needs to be. Are there things I can do to make my floor less expensive? Yeah, sure. Um, those stringers, the stringers are the long red pieces. There are actually 4 of them. Because they are so long, they cost a lot. So I could actually reduce my stringers. I just change it from 4 to 3. All right. And we can make sure that we're still okay. Yeah, our floor is just barely above 300, but we also just made our bridge even more efficient because it's cheaper. And we can even maybe go over here and a couple of these members like 1, 2 here. I just changed it to the cheaper balsa wood. And no, that's not going to work. So this is a good thing to do. See, I changed it to the cheaper balsa wood, but boom, it's touching that red line. So I got to put that back. That's not going to work. Okay. So you get the idea. But in actually a very short period of time, if I was talking and demonstrating so much, all you do is you're going to go in. Once you get enough points to go, for your first one's level 1, first thing you're going to do, maybe you want to screenshot this to remind yourself. First, review the specification, paying attention to size, capacity, and cost, okay? And when you set your bridge up, that's that very first box in right up here, the one at the top, bridge site and envelope. You want to set these to the minimum, all right? There's no advantage making your bridge bigger, longer, wider, taller than it needs to be, okay? Matter of fact, there's an incentive not to. It makes it too expensive, okay? So go minimize everything, and that will minimize your cost, which will maximize your efficiency. Yay, all right? Set up that load test right up front. Students, gosh, they forget to do this all the time. And here's what's going to happen if you forget to do it. You will be lulled into a false sense of security. So it defaults to 200, right? Boom. So you do this bridge and you think everything is wonderful. And then it's like, it's not, it doesn't meet spec because you're competing, you're testing this chart is showing you the wrong load. Okay. You never set it to the required load. When you get to another level, the required capacity is going to change. This should be the second thing you do, maybe even the first thing you do. Boom. Okay. So yeah, review that. Okay, review the spec, and then take the capacity that's in the spec and set up that line chart for you that shows you which members need to be improved and which ones can actually be made cheaper. And that's your very next step. Click on the truss system, say I want to see it, and it's going to draw that line chart for you. And you're going to go through, and the members that are failing, you're going to laminate them. And the members that have really low amount of load on them, okay, you're going to reduce those. Reduce means make smaller, all right? You're going to go with the smaller balsa wood. And if you do that, and then you check your design against your spec, guess what? You're going to have an in-spec bridge, okay? And you're ready to go in competition and start earning points. Now, I'm not going to, go through all the different combinations and permutations there are because there are quite a bit. I'm just going to say that I can do things like, actually changing the height of my bridge. Actually, you know what? It makes your bridge stronger. And sometimes you want to make it a little bit taller, make it smaller. You can also experiment with things like reducing the number of bays. I can go from 4 bays to 3 bays. Okay. And say, okay, um, is that going to work? Well, what do I have to fix now? Well, I got 1, 5, and 4, 6. So could I go with this? 1, 5, 4, 6. Laminate those. Boom. Okay. I have an inspect bridge now. That took me literally just a couple of seconds. It's extremely simple bridge, and my efficiency, um, not so great. Um, but oh, the floor is too weak. So I'd have to go over here and strengthen up the floor. Remember, I made the floor weaker. Anyway, I could go on all day about this stuff. Um, I could just add more stringers to the floor. Remember, I reduced it. And let's see if my floor is strong enough now. So all kinds of stuff you can do. My budget, what is my budget now? Yeah, this is down to $15. Okay. So anyway, there's all that stuff you can do, but don't get all wrapped up in that. Just get wrapped up in what's on the screen right here. Review the spec. Pay attention to size, capacity, and cost. Set up your load test right away to what the specification, the capacity specification is. Click on this. Oh yeah, and right here, minimize your size of your bridge. Step one, right? Review your size, capacity, cost. Minimize the size. That's just top 2 boxes in engineering. Set up your load test. View the truss system. Make the ones that are failing, laminate them. Reduce the ones that hardly have any load on them at all, and then go and look at your spec and say, hey, how am I doing? And so I made some changes. This is my latest version. And yes, look at this. I'm still in spec. All right. I could go in here and, save it, enter competition, compete again, get some more points. Okay. You get the idea. All right. But that's all you got to do. A lot of talking. Seriously, doing these steps, you get to where you can do this in like less than like 3 or 4 minutes. Okay. I put this up on the board in class and I tell the students, hey, I'm not kidding, follow these steps. The students that do follow these steps have a bridge, they are competing with their bridge and usually less than 5 minutes. Okay. I mean, it really is that fast. The students that like, no, I want to do my own thing, then they kind of beat their head on the wall for half an hour till I come by and I say, hey, you need some help here. There's some things you might be overlooking. But this is a simple approach. It is a very, logical approach. Minimize the size of the bridge. Make sure your test parameters are correct that are going to give you that chart. And then go ahead and strengthen the members that need to be strengthened and reduce the ones that don't. And that's it. I mean, that really is it. That'll get you there. This won't get you through every level, okay? But this will get you through, I promise you, this will get you through levels 1 and 2, all right? When you get to level 3, it gets a little more difficult, okay? And this video is not intended to teach you everything about every single level, okay? So, but that's it, okay? So, hey, good luck and follow these steps. Screenshot, all right? And you'll get through this pretty quick. You'll learn a lot about this stuff, all right? Have a good day. Bye.